So line, bar, pie, stacked, all these charts are there. Then, and then you have your histogram, box plot, and density curve. These are the univariate plots. And then the bivariate plots, scatter plot. So scatter plot, we'll talk about bivariate later. So univariate. Till now, whatever we are doing is univariate statistics, right? All the things which we have done, the measures of central tendency, all these things we have done till now is univariate. So these are also univariate plots, single variable. Okay. So univariate plots, and these are all your univariate statistics. Univariate statistics. Okay. Now, the simple command is plot. Plot Airbnb dollar price. So run this command. What you get is I think dot plot type is equal to L. Will give you the line plot. Type is equal to L will give you the line plot. There was a line plot in the right side bottom window, right? Type is equal to L, small l. Got it? So plot is a function which is there in Python, in R for plotting, PLOT plot. Similarly, if you go to the help and type plot, you'll get a lot of plot structures here. Okay, in the base plot library, so basic plot, this is the default version, X, Y, you can do scatter also. These are the types. P for points, L for lines, B for both, C for lines part alone of B, O for both or plotted, H for histogram. You can also use type is equal to H for histogram, S for state steps, capital S for other steps, N for no plotting. Okay. So these are the various things which you can give for arguments for plot. So if you want to create a bar plot, the input has to be a table, frequency distribution table. So in different types of plots, you can do in basic plot structure. These are the basic arguments you can give for plots. By default is points. Points means dots. Okay. So the documentation is very detailed with all the examples, everything. In some cases in algorithms, you'll get the research papers also, which are to be referred. The original research papers that were written for the original algorithms, they are also given in the research documentation. In Python also, they have added this feature 2 years back. Earlier, Python didn't have that feature, but now Python also, sklearn has the research paper reference also. So sometimes what happens is, in some cases, when you're doing advanced models and all, you have to constantly refer to the research papers also. For some theoretical background or information related to model and all, the equations and all. So that's why a paper reference is also required. So try type is equal to H, you should get a histogram of price. H is a small letter. It didn't come. So see here. So you got the price line plot. Actually, this is not the correct plot. You got it like this, right?
Yes.
Copy paste, Control C, Control V, equal to. You can see trapezoidal touch is not working. So we'll do it separately. So if you want other plots, you can do pie diagram or pie chart. Defunct is pie chart. The one right now is pie. So pie Airbnb dollar room type comma oh table we have to give frequency table we have to give table like this. See? So we have to adjust the width and height. So we can do pie chart with a frequency table. Hist. Hist is for histogram. This is the histogram. Box. What something you didn't get the same? Now you can just expand the window, plot window. Just drag this plot window to a bigger one. See, the plot window has to be maximized. And scroll towards the left. Plot density Airbnb dollar price. This is the density plot. Histogram, box plot, and density plot. Because the skewness is very high, everything is towards the left. High positive skewness. 25, no? Which is extreme skewness. So the three critical plots that we generally do is this. All right. Now, for non-numeric data, this is for numeric data. Whatever we have done is for numeric data. For non-numeric data, all we can do is frequency counts. Cross tabulation. Frequency counts and cross tabulation is what we can do for non-numeric data or character data or categorical data. When your data is categorical or non-numeric, you can do this. So the function is table. Table Airbnb $room type. You can see here the output entire room apartment 3828, hotel room 88, private room 1792, shared room 24. Frequency counts. Table Airbnb neighborhood group. Neighborhood. So we have these neighborhoods. Centrum. So you have all the different neighborhoods and rooms by neighborhood. Table. Same thing is value counts in Python. Here it is a table. So minimum nights, you can create a table like this. See here. Neighborhood will get a lot of, here. Centrum was. No, that's what. No, you have to use neighborhood, not neighborhood group. It's neighborhood, not neighborhood group. Now, if you want percentages of table, we have something called prop.table, table of Airbnb $room type. Percentage, yeah. Proportion table. So 66% are home apartments, 1.53 are rooms, 31.26 are private rooms, 0.148 are shared rooms. So for cross tabulation, which is frequency count of two categorical frequency table of two non-numeric Again, it is the same table function, Airbnb dollar neighborhood, comma, Airbnb dollar room type. So we'll get room type wise, entire home apartment, how many are there? Each hotel room. Okay. Cross tab, pd.cross tab. Pd.cross tab is the cross tabulation. Now, group by is your aggregation. You have as dot integer, as dot numeric, as dot character, as dot factor, dummy variable encoding. We call it as factors here, as dot factor. So you have as dot, and then you give the data column reference, it will convert the whole data into that particular format. So data aggregation, which is similar to your group by function in Python. Here we have the aggregate function. Aggregate Airbnb dollar price tilde. Tilde is your horizontal S symbol below escape. Airbnb dollar room type, comma, fun is equal to mean. So this is the similar to your group by function in Python. Tilde, horizontal S symbol below escape. So the left side of tilde is always numerical, right side is categorical, and then you have to specify the statistical function. Fun is your statistical function. Group by also we have the same. Left side of the group by is numerical, right side is categorical, and then you specify a statistical function. Here also we have to specify a statistical function. Fun is equal to mean. It can be same thing, you can copy. Fun is equal to median. Fun is equal to SD, standard deviation. So any statistical function you can specify. You can also, since psych is active, we can specify skew also. So aggregate is a function which is equivalent to your group by function in Python. Grouping of data based on certain conditions and parameters. Left side is numeric, right side is categorical. Price is numeric, room type is categorical. Similarly, if you want to get the aggregates by room neighborhood, aggregate Airbnb dollar price tilde Airbnb dollar neighborhood, comma fn is equal to mean. Directly close it. It will ask for save, and then click on save. Wait till it saves. So neighborhood wise average. Hello. No. Okay. So similarly, aggregate Airbnb dollar number of reviews filled Airbnb dollar room type comma FUN is equal to mean based on number of reviews, average number of reviews. Can we give multiple functions? Function is equal to C of mean. No. So we can do number of reviews. Number of reviews by neighborhood. So backend it will split the data into 4 different data frames. In the backend, it will split the data into entire home apartment, one data frame. Hotel room, one data frame, private room, one data frame, shared room, one data frame, and 4 data frames average it is calculated. And then it is giving us the output. So in the backend, it will do that thing. It will subset based on the levels, and each level, each class or each level's average is calculated and displayed. So backend, it will do the subsetting, and then it does the average calculation. Aggregate Airbnb dollar number of reviews from Airbnb dollar neighborhood FUN is equal to mean. What will be the- So you get the neighborhood wise reviews. Okay. So bivariate statistics, which is your correlation and covariance. Bivariate is correlation and covariance. So Airbnb BF, Airbnb square bracket C of 10, 11 COR COV. So we are trying to find the correlation between price and minimum nights. So there is a negative correlation between the price and minimum rates or minimum nights. If you give the 12th variable, so number of reviews. Again, negative correlation between number of reviews also. Negative. Strong is 0.560. Very strong is about 0.90 or 0.70. Some people say. So scatter plots can also be done. Bivariate plot is scatter plot. You can do individually. Plot Airbnb dollar price, comma, Airbnb dollar minimum nights. You can see here the scatter plot, completely negative correlation. So sometimes we also use pairs. Where you can plot multiple variables, correlation plots. Pairs. Yeah, row means, but row wise we don't calculate, no? How you have text data row wise, how will it come? It will give an error saying that non-numeric data is found. This thing can be done only on numeric data. That's why I'm selecting 10, 11, 12, which are the numeric variables. The rest of all are non-numerics. So we will get non-numeric found error. So to avoid that, we are using this what you call numeric variables only. So if you look at your summary, the same variables, all the three numeric variables, price, minimum nights, and this. Okay. You can see the summary of the three variables, three numeric variables. So if you try to do summary of non-numeric variable, say room type, it will give an error. So what it will do is, see, it says room type length character. See, room type is character, right? So summary will not work on character data. Okay. So if you give any character data, it will simply say non-numeric form or length character. It will simply say length character. But if you convert it into factor levels, then it will give you the frequency counts. Factor levels is your dummy variable encoding. Once you convert it into dummy variables, it will give you the normal output of frequency counts. So take for example, if I convert room type, Airbnb dollar room type is equal to Airbnb, sorry, as dot factor Airbnb dollar room type. So I am converting the character to factor. To factor, which is nothing but dummy variable encode, which we do using label encoder or PD get dummies, right? That time we use it. Now, if I do summary of this variable added, so we will see it is giving the frequency counts. So if the variable has been converted into factors, for non-numeric data, it will give you frequency counts. For numeric data, descriptive statistics. But if your data is in character format, it will not give you. It will, if the data is in character format, summary function will not work. So we will be converting them into factors. Once we do the missing value imputations and all those things, we have to do that here also. Hmm? So similarly, if you neighborhood is a large variable, we'll do it later, conversion. But and one other thing which you need to understand is L apply. L apply applies a function on column. S apply applies a function on rows. So there are two types of applies in Python, where in R, which you need to understand, which you constantly use. L apply and S apply. S apply applies a function on rows. L apply applies a function on column. Now we don't have, in summary, we don't get standard deviation, right? We are not getting standard deviation for all the, as part of summary. As part of summary, we are not getting the standard deviation. So what we can do is L apply. First, we need to give the data reference Airbnb 10, 11, 12. Airbnb 10, 11, 12 data reference, comma, the function name SD. Airbnb 10, 11, 12, and then gives you the. So you see, you can get the standard deviation of each of the numeric variables. So it is calculating the columns, complete column standard deviation. So similarly, I'll apply comma SKEW. I want skewness of all three variables. See, we'll get the skewness of all three variables. Similarly, I'll apply and copy it. Kurtosis. We'll get the kurtosis of the three columns. So when you want a multi-column output, you have to use L apply. But that is single variable. We are here getting multiple variables. Here, Suppose your data has 30 variables. You want to calculate skewness of 30 variables. In Python, we can do that. Data frame dot skew, it will give you the skewness of all variables, numeric variables. Here you have to use LFI. So this LFI is very important because once we have cleaned up our data and once you have your object columns ready, then we use LFI to convert our data from character to factors. That dummy variable encoding, where LFI is one of the very important function. See, the process is all same. Functions are also almost same. Correlation also .cor, .cov. See, it's all same. They are keeping it as close as possible, so that it's very easy to run because in real time you have to work with both. Real time data science you have to work with both. You can't say I will only work with Python. No, you have to work with both Python plus R. Some data projects are coming in R where clients insist we want only R outputs because they know statistics, they can understand. People who don't know statistics, they will say, okay, Python is okay with this. So then it all depends. The other day, one of the person called me. I trained him 2 years back. Cluster analysis. They could not do regression, was not fitting on sales data. So ultimately, asked me what should I do. I said clusters. He did k-means clusters. When he is predicting, the cluster labels are changing. It will change because the cluster label are randomly assigned. There is no fixed rule that cluster one of the trained data and cluster one of test data will be same. They will be different. That we have to manually map. We have to calculate the centroids or means of each cluster and we have to map them. So he was saying, what to do with all this. So he tried R, he tried Python, SAS, everywhere same thing. But finally, the client said, send me the R output because R gives you statistical output with all the centroids, cluster labels, variance, everything it will give us. So a lot of things are there in R which will help us. So in case of random forest, we don't know how many trees we need, right? In R, we can find out. At what tree the variance is becoming straight line. That means there is no change in variance. That means the beginning of the straight line will be our point at which we will take the number of trees. Right. So till which point there is a variation, that point will take, after which, even though you give that many trees, no point. So that all things we can do in R. So we'll stop here and we'll continue in tomorrow's session. Tomorrow we'll work on a new data. I'll send the file.
Sir, Sitaram here.
Yes, sir.
Sir, there is one hackathon is happening for agriculture data, which is starting on 15th.
Okay.
Can we try that one, sir?
Yeah. Which website?
I will send that in chat box, sir. No. So I shared the link in the chat.